So we've got some mole calculations to do in this video. Mole calculations, or calculating quantities calculations. Let's have a look at this first one here. How many grams of calcium oxide? So the first thing we're going to do is we're going to decorate this equation with this information, because that's quite important to helping us understand what's going on. So how many grams of calcium oxide? That's the calcium oxide there. So question mark, grams on the calcium oxide. That's what we're trying to find out, the mass of calcium oxide. I'm made from 160 grams of calcium. So we're going to write 160 grams of calcium above the calcium there, and excess oxygen. Now, because that oxygen is in excess, it means we can cross it out. It means that doesn't impact how much product is made in this reaction, because there's too much of it. Excess means too much. It means the amount of calcium oxide is solely dependent on the amount of calcium that is present. Okay, so these calculating quantities calculations, there are a couple of different ways they can be done. Okay, the way I'm going to teach you and the way I'm going to go through in this video is in a three-stage process, where the first stage is moles, one. The second stage is going to be stoichiometry, and the third stage is going to be moles. I'd like you to write it out like that, please. Okay. Now there is other ways to do this. There's a method in that's often seen in the CGP revision guides. You can do it if you understand it and get the right answers. That's brilliant, and you should use that. But I'm not going to do that way, because I want you to understand stoichiometry, and that's quite important for understanding GCSE chemistry and progressing to A level, I think. Okay, so none of these stages are particularly difficult, but actually it's really, these are difficult questions. Okay, so they are supposed to be hard, and it's generally the students who get these right get grades 7s, 8s or 9s. So it's worth persevering with them, but they are tough. But none of the stages are tough, but it's remembering how to put them together. First stage, moles. Well, moles, if you remember, equals mass divided by atomic mass, or formula mass. So we're going to do atomic mass here, because in stage one we find out the amount of moles of whatever you have been given the mass of, and that's why I like you writing this above the equation, because we can see we've got the mass of calcium. So we're going to calculate the mass of calcium. So mass is 160. We know it's mass because it's got grams at the end of it. That tells us it's a mass. The atomic mass now. If we have to calculate a formula mass, we'd do this here now, but we don't have to calculate a formula mass for this one. It's just calcium, it's just an atom, and there it is there, 40. Okay, you may be saying, well, why don't I write 80 underneath as 2 calciums? Well, let me ask you this. If you happen to have a twin brother or a twin sister, okay, and you wanted to weigh yourself in the morning when you got up, okay, would you invite them to stand on the scales with you? No, it's nonsense. It's ludicrous. You want to know the mass of you, not the mass of 2 of you or 3 of you or 5 of you. So these big numbers, they do not come into formula masses. Okay, so it's 160 divided by 40, that is 4 moles. Okay, that's stage 1 done. As I said, none of these stages are particularly difficult, just remembering how to put them together. Stage 2, stoichiometry. Stoichiometry is the big numbers in the equation. That's what we mean by stoichiometry. What are the reacting ratios? Well, here we've got 2 calciums. Okay, in this equation, 2 moles of calcium make 2 moles of calcium oxide. That's what that big number tells us. And the question you have to ask yourself now is, are these numbers the same, or is one bigger? Well, that number is the same as that number, so this stage is now ridiculously easy. We don't start with 2 moles of calcium though, but we have calculated we start with 4 moles of calcium. So if 2 moles of calcium make 2 moles of calcium oxide, it follows that 4 moles of calcium must make 4 moles of calcium oxide. So we are looking in the trend of these numbers here, and the fact they're the same means these are the same. That's stage 2 done. 4 moles of calcium oxide. Okay, let's just put a line down there to keep things separate for a second. Stage 3, moles. We're going to use this moles equation again. Moles equals mass over atomic mass, but we need to rearrange it now, because we want to find out the mass of grams of calcium oxide. So we can put that into a formula triangle. Every formula triangle is the same. Well worthwhile remembering this. Okay, mass is on the top, moles, and formula mass is on the bottom. So we want mass this time. We want the mass in grams of calcium oxide. Put our finger over mass, moles times mR. Let's write that out. Mass equals moles times mR. Formula mass. mR is an abbreviation for formula mass. Now we are trying to find out the mass of calcium oxide, so we have to calculate the formula mass of calcium oxide here. So there's one calcium in calcium oxide and one oxygen. There's no number after the calcium, there's no number after the oxygen, so it could be Ca1O1 written like that. We don't bother writing the ones out though. One calcium and one oxygen. Well, one calcium is 40 and one oxygen is 16. So 40 plus 16 equals 56. Okay, so that's the formula mass now of calcium oxide. That's right at 56 down there. Now we want to multiply that by moles. Now the moles of calcium oxide we calculated in stage 2. We said there was 4 moles. So 4 times 56. 4 times 56. 4 50s are 200. 4 60s are 24. So 224 grams of calcium oxide. And there is our answer. Okay, 3 stages. 1, 2, 3. Everyone needs the same. 3 stages. We've got 10 examples, so let's go through a couple of others of them. I'll give you the answers, or close. I'll give you approximate answers to some of the others. So the approximate answer to number 2 is not exactly. You need to work it out now. 500 tons. Working is what I'm interested in. If your answer is about 500 tons, it's right, but I want you to calculate the exact answer. You may say, well, this one was grams, this one's tons. How do we do that? Just treat it in exactly the same way. Instead of starting with grams, you start with tons and you finish with tons. So we do it in exactly the same way, but instead of writing grams at the end, we write tons at the end. Okay, if you didn't get that, we'll do one like that in a moment. Number 3, the answer is about, not exactly, 70 grams. Let's do number 4 together. Okay, how many tons of ammonia? Ammonia is NH3, so ammonia is NH3, so that's the question there. And we're going to write tons at the end of it. Okay, quite important. Let's underline that tons because it's different. Are made from 56 tons of nitrogen, so 56 tons of nitrogen and excess hydrogen. It says assume 100% conversion. This is because this is a reversible reaction. That's what that symbol means. Let's not worry about it right now. We're assuming it's all converted. In practice, it won't, but let's just do this calculation. Right. So excess hydrogen. Cross out the hydrogen. Right. 3 stages. 1, moles. 2, stoichiometry, and 3 moles. Okay, same 3 stages every time. Moles equals mass over formula mass. Okay, mass 56, and formula mass this time. So we've got nitrogen, we've got an N2 molecule. Okay, well, nitrogen has got an atomic mass of 14, so 2 14s. This is a little 2 now, so this is a formula. So it's 14 plus 14 is 28. 56 divided by 28 equals 2 moles. Okay, stoichiometry, and this is the reason I wanted to go through this one, because the stoichiometry on this one is different. N2 makes 2NH3. Okay, question, are these numbers the same? Now, there's no number before the nitrogen, so there is, of course, a number 1 there. Are those big numbers the same? 1 and 2? No, they're not. Of course they're not. Okay, how do we get from 1 to 2? That's what you have to ask yourself now. We get from number 1 to 2 by multiplying by 2. Okay, now we don't start with 1 mole. We start with 2 moles. So we've got 2 moles. So if we had to multiply 1 by 2 to get to 2, we need to multiply the 2 by 2 by 2. 2 times 2 is 4. 4 moles of NH3. Okay, now is that stage done? So we are looking at the relationship between these numbers. And then once we've worked out what that relationship is, we apply it to whatever number of moles we calculated. To get from 1 to 2, we had to multiply by 2. We start with 2 to get to 2. We have to multiply by 2 to get to 4 moles of NH3. Okay, so that's that stage done. This stage here now. Mass, because we now want mass, equals moles times MR. We're using the moles equation again, we're just rearranging it. Okay, the MR of NH3, so there's 1 nitrogen and 3 hydrogens. Nitrogen is 14 and hydrogen is 1. There's 3 hydrogens, that's going to be 14 plus 3, 17. So that's going to be 17 there. Times the 4 moles here, well 4 times 10 is 40, 4 7s are 28, so that's going to be 68. 68. Now remember, we started with tons. Okay, 56 tons, didn't we? We started with 56 tons of that, so we're going to finish with tons, 68 tons. And that is our answer. Okay, number 5. The answer is roughly 320, roughly, tons. Okay, so you need to work out exactly what the answer is. Question number 6. Okay, question number 6. The answer is roughly, oh, it's a very big number, isn't it? Roughly 600,000 by the looks of it. Okay, so you're getting an answer roughly 600,000 tonnes. Number 7, the answer is approximately 7 times 10 to the minus 3 tonnes. Not exact, you need to give me exact answers. Right, number 8. Let's do this one together quickly. Okay, this is a bit different again. What mass of chlorine? Well, there's a chlorine. Okay, is needed to produce 25.4 grams of iodine. Well, there's the iodine, 25.4 grams. Okay. Right, well, this time you may think, say yourself, well, this is different because we're given a mass of a product and asked to find the mass of reactant. Well, yeah, but it's exactly the same. We just work backwards. Moles is the first one. Stoichiometry is the second. These all go moles, stoichiometry, moles. And number 3, moles. Okay, what do we find out the moles of? Moles equals mass over formula mass. What do we find out the moles of? We find out the moles of whatever we're given the mass of. We're given the mass of iodine. Okay, iodine has got a formula I2, so it's 127 is 1, so that's going to be 254 for 2. So the mass is 25.4. We know that because it's got a unit after it, grams. The formula mass, 254. That's 2 iodines, 227s. That's going to be 0.1 of a mole. Okay, this time, well, I say we're working backwards. Okay, so we've got this. We can write it whichever way we want, I suppose. So the question is, chlorine is there, okay, and iodine is there. Now it's a 1-to-1 ratio, so the number is the same. That's the question, isn't it? What is the number the same? This time we've got 0.1 of a mole of iodine. Okay, and we're going to work backwards this time, not forwards. We've gone forwards in every other example. Now we're going backwards. That means that's going to have been made by 0.1 of a mole of chlorine. Okay, so it's exactly the same as the previous 7 examples. We're just going backwards. If that had been a big 2 there and that had been a big 1 there, would have divided by 2 would have halved it. Okay, but it's not like that. Although possibly the next one might be. Have a think about that. So we've got 0.1 of a mole over here now. Mass equals moles times MR. Okay, so we've got, we need the MR of chlorine, that's Cl2. 1 chlorine is 35.5, so 2 is going to be 71. We've got 0.1 of a mole of it, 0.1 of a mole times 71, 7.1 grams. Number 9, I've asked you to do this to 3 significant figures. Okay, I'm going to tell you right now the answer is not 1.42 kilograms. It is not that, but it's very close. Okay, so it's close, but not 1.42. Okay, so what is it if it's not 1.42? And number 10, the answer is roughly 20 tonnes. Roughly 20 tonnes. Okay. So, 10 questions. They are difficult, and you may struggle, so you may need to ask your teacher. That's absolutely fine and normal, and you'd be, to be honest, you know, if you can rattle through all 10 without any help, you're doing pretty well, very well indeed. So it would be normal to ask for help on them. So don't worry if you feel you need to, or if you don't get them, then just stop and ask questions next time you see a teacher. Okay, good luck.